In this video, we're going to talk about how the common ion effect affects solubility, just like it does in buffer solutions. For example, let's take two chemicals that have a similar ion. Let's consider silver nitrate and silver chloride. If these two species were to dissolve completely, you would get silver ions, nitrate ions, silver ions, and chloride ions. So you can see in these examples that both of these chemicals have the ability to produce silver ions. Now, the silver nitrate in this case is generally considered completely soluble. So you can consider that to split apart into its ions 100% of the time. On the other hand, the silver chloride will have a reported K value, something like 1.6 times 10 to the negative 10, which will show you that this particular chemical does not split apart all the time. This lets you know that you're going to have the type of problem where you have to consider two types of starting materials, just like you would in a buffer problem. You also need to recognize that the nitrate in this case is considered a spectator ion. So you don't need to consider it in your calculations. The main purpose of considering the common ion effect with solubility is to notice that if you add additional sources of ions that your slightly soluble compound can make, that the slightly soluble compound will not dissolve as much as it usually would. Now let's do a practice question that I found in your textbook. In this example, we are asked to calculate the molar solubility, where we usually use the letter S to represent that, and the units will end up being in molarity, for silver chloride in a 6.0 times 10 to the negative 3 molar solution of silver nitrate. Now, in a question like this, I know that I need to go ahead and find the K value for silver nitrate, which again is 1.6 times 10 to the negative 10. And I would usually look up that value in a textbook. There'll either be a table within the chapter or in an appendix at the end of the book. Okay, now that we have enough starting information, I need to figure out what exactly is in my container. When I look at this question, I see two different things. I see my slightly soluble material, where I will probably start with a solid silver chloride, and it can split apart into silver ions that are aqueous and chloride ions that are also aqueous. And I see that I have silver nitrate around. Just like we talked about, silver nitrate has the ability to produce silver ions and nitrate ions. The ones that are important for this question are the ones that produce a common ion. I'm going to put the value for my silver nitrate's silver ion contribution in the initial box in my rice table, because I'm starting with that much in solution before dumping in my silver chloride. So since there's a 1-to-1 ratio between silver nitrate and the silver ions, I'll go ahead and put my 6.0 times 10 to the negative 3 inside of my starting area. Since I'm not starting with any chloride today, I'll put a 0 here. Please also remember that you're not supposed to put any numbers in the rice table for a solid, as they're not included inside of the equilibrium expressions. Okay, now I would set up the rest of my rice table, adding an X to both of these boxes, or in this case you can use S for solubility, that's fine too. And I know from my K value being so much smaller than my starting concentration that this particular X, or S value for today, is going to be so small that I don't need to write it down. Now I just need to set up my equilibrium expression where my KSP is going to be equal to my silver ions multiplied by the chloride ion concentrations. Enter in my numbers. 1.6 times 10 to the negative 10 equals my silver number, 6.0 times 10 to the minus 3 times the molar solubility, and solve for my S. So my molar solubility for this compound in this particular situation will be 2.7 times 10 to the negative 8. And honestly, this number is a lot smaller than what you would regularly get for silver chloride in water. And that's kind of the point of this whole thing. If you have an extra common ion inside of your solution, it's going to make your solid resist dissolving into the solution. The wording in these questions can be pretty tricky, so make sure that you practice a whole lot.